All right, this next one says, given these two parametric equations, find the derivative dy dx and find both coordinates of all points with a vertical tangent. Okay, so first if we're going to find where this has a vertical tangent, we're going to need that derivative dy dx, so let's find that first. So we want to find the derivative of both those two functions. So dx dt here is going to end up being 3t squared minus 6t, and derivative 1 is just 0. Our dy dt is going to end up being 2t plus 1. All right, so what is our dy dx now? So dy dx is dy dt over dx dt, so it's going to equal 2t plus 1 over 3t squared minus 6t. So that's the answer for part A, or the first thing they wanted us to find. And they want us to find both coordinates of points where there's a vertical tangent. Well, if some graph has a vertical tangent, like I don't know, maybe the graph of this looks something like this. If we want to find where it has a vertical tangent, we know the slope of a vertical line is undefined. So what we got to figure out is, in this equation, what values of t would make it undefined. So if you have a vertical tangent line, that means slope is undefined. Then what we want to look is slope's undefined when denominator equals 0. And so what we want to do is set that denominator equal to 0 and solve it out. So let's do that. So we got 3t squared minus 6t, set that equal to 0. We can do some factoring here. Looks like you can factor out a 3t. So that means we got t minus 2 left there. Putting both of those equal to 0 now and solving would give us 0. And it also gives us 2. So at a t of 0 and a t of 2, that's when this is going to have a vertical tangent line. They did want us to find where are those points now. So let's find those points. So the points here, when t is 0, let's find that one first. So that would be just plugging in 0 for both of these. If you plug in 0 for the x one, that's just going to be 1. If you plug in 0 for the other one, 0 squared plus 0 is just 0. So one of the points is 1, 0. That would be 1. The other one would be at t equals 2. So to find those, plug in 2 here. So you got 2 cubed minus 3 times 2 squared plus 1. That's going to be 8. Minus 12 plus 1. So negative 4 plus 1 is negative 3. Find the same with y now. 2 squared is 4 plus 2 would be 6. So the other point would be negative 3, 6. So these would be the 2 points where there's vertical tangent lines on this graph. All right, next one, kind of similar, where they're wanting you to find a derivative and then answer some questions about the range of x and range of y. Why don't you pause the video, see what you can come up with for this one. All right, let's see how you did here. You got to find what's the derivative of dx dt. So probably want to think of this as x to the, or t to the 1/2, and then derivative then would be using our power rule right here. Derivative of y in terms of our parameter t would be 2t minus 4. So dy dx is our dy dt over dx dt, which you see here. Depending on how far you simplified, I moved this t down to the denominator here and then multiplied by reciprocal, which would be that, and distributed to simplify. If you got, as long as you got somewhere in there, that should be pretty good. All right, the next one, find the range of x and the range of y. Our parameter here is that t is going to be greater than or equal to 0. So if you put in that smallest value of 0 into the x1 up here, square root of 0 would be 0, plus 1 is 1. And any number you put bigger there is going to keep growing. So it looks like x is going to be all the numbers 1 to infinity. For y, if you put in 0, you're going to get -4. And I think that's the lowest it'll go if you put numbers bigger in there, like 1 square. If you put 1 in there, it's going to be -3. 2, put it in there, it is going to go back to -4. 3, it'd be -3, and all the other values are bigger, so lowest this is going to be is -4 to infinity.